Hi, everybody. Welcome to week 12 of Graduate Statistics. This is the lab portion. And in this lab, you practice creating scatter plots to examine relationships between variables, compute the correlation coefficient, and test whether it's large enough to dismiss the null hypothesis. That I shouldn't say R here. That rho equals 0. The correlation in the population equals 0. We'll practice modeling the relationship using linear regression, and you'll learn how to use the estimated models to make predictions. Let's do that. All right. Correlations. Everything correlates with everything, which Paul Mill calls the crude factor, also known as ambient correlational noise. Our goal today is to determine how much, and we'll deal with 2 variables today, but we'll soon explore the problems with 3 or more variables. So that everything's correlated, we know. How much so, right, is the question. Is it sufficient for us to believe that these 2 things are truly dependent and mutually influencing each other? So we worked in the lecture portion with Pearson's correlation, which is that correlation that estimates that R value in the sample, the correlation in the sample, in that which is an estimate of the rho, which is the correlation in the population. So it's the most common type of correlation you will encounter, and it is a parametric method, which means it's best when used when you have the response variable continuous, right? The predictor variable, the explanatory variable, can be either continuous or not, but definitely you should use that analysis when you have a response variable that is continuous. If both are categorical, chi-square is your friend. So we talked about this formula, and the numerator again is how much 2 variables vary together or co-vary with respect to how much they kind of move around without influencing each other. And the value is bounded between -1 and 1. The first piece of this lab will do with made-up data because I wanted to be able to modify the relationship so that you can compare scatter plots showing a very strong relationship, moderately strong, weak, and no correlation at all, right? So let's explore this silly question. Is there a relationship between happiness and how much ice cream one eats? More specifically, is ice cream consumption a good predictor, a good explanatory variable for happiness? So ice cream consumption is our predictor or explanatory variable, and happiness is response. I'm belaboring this point of defining which is which because that determines which variable you put on your x-axis, which variable you put on your y-axis. And that is also going to determine which variable you're going to enter as the response variable in the regression analysis, and which variable you're going to enter as the predictor of the regression analysis, because that changes the line a little bit, even though it doesn't change the correlation coefficient itself. All right, so first thing, we're going to load data. We're going to load actually 6 data sets that I made describing the relationship between happiness and ice cream. Each data set will represent a relationship of different strength and different direction. And the relationships will vary. Relationships will also vary in direction. Our task is to order the data sets, is to look at the data sets and try to estimate the direction and strength of the relationship. This thing will be fixed when in yours that you're probably looking at right now. So my goal with this activity is to get you used to looking at scatter plots and getting a sense of the strength and direction of relationships. So let's describe the data and interpret the relationships suggested by each data set. So I'm loading all of them. All of them look generally the same. It has a variable called happiness. Note that it's capitalized, and a variable called ice cream. The variable ice cream is telling like the ice cream consumption how many ice creams a month a person eats, or how many ice creams a week. You can think about it this way. And happiness is the score on a happiness scale. Okay? So let's go and get back to our thing here. Hang on. Okay, so here we are. So we loaded all of them. They all sort of look the same. I just played with the numbers a little bit and did some simulations in order to get different types of relationships. All right, so here we are. Let's do descriptive statistics. As we saw in Lab 4, a scatter plot is the plot of choice to describe relationships between variables. I'll get us started with a data set, with one of the data sets, the first one, data set happiness, instead of happiness 2, 3, 4, 5, and 6. And you will do the rest. I'm doing this here because I don't want you to have to waste time going all the way to Lab 4 to find this, but you've seen this before. And if you're confused about the syntax, you go back to the videos of Lab 4, where we go over in details, to the lab of Lab 4, where I go over in details on the syntax of ggplot. But very briefly, ggplot takes as the first input the name of the data set, which is happiness. It also takes an aesthetic function, which is where we tell R how to map things in the data set with aesthetics in our graph. So we're putting ice cream on the x-axis because we chose ice cream to be our explanatory variable. And we are putting y in happiness in the y-axis because it's the variable we're choosing in this fake problem as our response variable. Here is where you play around with points and shapes and color and everything like that is, if you want to review, it's back in Lab 4. And we're playing with the title. The subtitle is source made up data set 1, and you have ice cream on the x-axis and happiness on the y-axis. And if we do this, we shall see the data cloud. I wonder if I can make this a little smaller so you guys can see it all. But you certainly can see on your own computer. You can imagine a line going through here, and you can see you have like a big white triangle in each side. It suggests that we have not very tight, strong relationship, but strong to moderate relationship. It's one of those that will be somewhere between 0.6 and 0.8 that we explored in class. So if you were to guess what is the direction of this relationship, what's the strength of this relationship, we would say something like positive, because as one goes up, the other goes up. The more ice cream someone eats, the happier they tend to be. I'm not saying it's causal, but in my fake data here, we're saying that they go together. Sounds right to me. What I want you to do now is to pause the video and create a scatter plot for the other data sets, and then try to answer and make a guess about what you think the type of relationship is. All right? After you do that, you come back and we'll do this together. Okay? See you in a bit. All right. Hopefully you tried this on your own. I think it makes more sense. But all you would have needed to change from the scatter plot, from the initial syntax, is the name of the data set, because the variables inside are the same, right? And the other thing is that the source is a little different. Instead of being the data set 1, now it's data set 2. But everything else could stay the same, right? But when you're using this code, make sure that there are things that you always need to check. Is this the data set that I want to look at? Is this the variable that I want to put in the x-axis? Is this the variable that I want to put on the x-axis, in the y-axis? You have to make sure these you have to change all the time to create the scatter plot itself. And then the title and the x and the y should be changed to match up with the type of data set you're dealing with. If you always want circles and blue dots, you don't ever have to change this one. But if you want to have X's instead of blue little dots, if you want filled dots instead of empty dots, all of that can be changed. am not going to go over this again here, but again, this is all explained in your guided activity, Lab 4. So look at data set 2. Compared to this, where our cloud or elongated cloud that suggests that a relationship is there, it's very different from here, right? This is much tighter. So we would expect this to be a positive and strong relationship. If we now look at data set 3, we see now a negative, not as strong, not as tight, right? So negative and moderate relationship. If we look at happiness 4, we see a negative but much tighter relationship, a negative and strong relationship. And if we look at happiness 5, let me run this here. You see pretty much a circle here. I would expect this not to be a significant relationship. The best fit will probably be a horizontal line, more or less, right? So that would be a no correlation type of plot. And this last one will be sort of a weak correlation, because if you look at these corners, we end up seeing some variables in them, some dots in them, right? So you have what it seems like a nice line here, but then lots of points that are very, very far away. That will make the correlation a little bit weaker. So negative and weak, right? It's kind of going down like this, but sort of weak. So, as I said, of course, it's very good to train your eyes and be looking at data when you look at the scatter plot to know what to expect. Because if there's something wrong with your code and, I don't know, R estimates a very high and significant relationship in a plot like this, I would be like, okay, something went wrong with my code. Maybe I'm looking at a different data set. I forgot to change the name, right? So it's good to look such that the numbers are sort of confirming or disconfirming what you're thinking. So always start there, okay? But you actually can estimate and check things out, right? By actually running a correlation test, both to estimate the R, the correlation coefficient, and to determine if that coefficient is large enough for us to say or reject the null hypothesis that rho, the correlation in the population, is 0, right? So it's a very, very easy function to run. Here's what we do. It's always important to store your results somewhere if you want to look back at it later. So I'm just going to call it core.happy because it's my first data set. And the function is core test, and it takes as input the 2 variables that you want to analyze. The order does not matter here. It will matter in regression, but not here. So happiness is the name of the data set, and happiness is the name also of one of the variables inside the data set. So I have happiness and happiness. But if, the second here, I'm not repeating the name of the data set. It's just that in this case, the name of the variable inside the data set is also happiness. All right. The second variable, here's the data set, and the second variable is ice cream. All right. And the method of analysis here is Pearson correlation. That's the one that will give you the R that you want. To print out the output, just type the name of the object in which you kept this all. So you can change and name your model whatever you want here. On this side, you cannot do whatever you want. You need to put in the data set and the name of the variable, the name of your Y variable, the data set, the name of your X variable. The order here, again, does not matter because the R, the correlation coefficient, is not influenced by who is in the Y or X axis. The equation of a line is influenced, but the strength of the correlation is not. So if you run it, here's the output that we're going to get. We get the T value. Remember, you transform the R into T, and you have the degrees of freedom because that's what implicates the distribution in which you're going to look for the probability of seeing a T of 7.4 or larger. And we can see that the p-value is very, very tiny, 0.0001004. So we reject the null hypothesis, right? True correlation is not equal to 0. Rho is not equal to 0. And here we have a 95% confidence interval. that tells us that we can expect our correlation coefficient to be somewhere between 0.44, 0.45 and 0.71, right? And the average correlation is 0.6. So moderate low, right? So the average is 0.6, which is in the moderate range, but the confidence interval tells us that it could be somewhere between sort of lower correlation strength to a higher correlation strength, right? In the moderate range. All right, so the correlation coefficient indicates a statistically reliable, moderate positive relationship, as the plot suggested, with 95% confidence. We can say that the correlation between ice cream consumption and happiness is between 0.45 and 0.71. All right, now stop again and try to run this correlation over and over for happiness, data set happiness 2, 3, 4, 5, and 6. When we come back, I'll stop the recording, but the next recording we'll go over the results and see if things match up. All right, see when you get back. Bye-bye.